This video is about trigonometric integration. There are a few different parts to the trigonometric integration section. One involves powers of sine and cosine. So let's say you've got this, the integral of cosine to the m of kx times sine to the n of kx. Notice the angles are the same. Both sine and cosine are evaluated at kx, and the cosine function is raised to the mth power and the sine function is raised to the nth power. In this section, we're going to solve integrals like this with a u substitution, and the form of the substitution will depend on whether m is odd and positive or n is odd and positive, or if both the powers of cosine and sine are even and non-negative. So let's see. There are going to be three guidelines for powers of sine and cosine. If the power of sine, that's the n in our formula, is odd and positive, you're going to save one sine factor for du, and you want to let u equal cosine of kx. So if the power of sine is odd and positive, we let u equal cosine of kx. Then the derivative of u is negative sine of kx times the derivative of the inside, which is k by the chain rule. So that's the derivative, and we multiply that by dx to get du. And then once you do that, you're going to factor out one of those signs, and you're going to be left with an even power of sine. You're going to use the fact that cosine squared of some angle plus sine squared of the same angle equals 1. To write all the remaining sine factors in terms of cosine. So in this case, if my u is cosine, I want everything else to be in terms of cosine. So I can solve this Pythagorean identity for sine. Cosine squared plus sine squared is 1. So sine squared is 1 minus cosine squared if I subtract the cosine squared a from both sides. So I can replace every sine squared with 1 minus cosine squared and then evaluate the integral. So that's one of our guidelines. The second guideline is almost exactly what you would expect. If the power of cosine is odd and positive, we're going to do something very similar. We're going to save a cosine factor for du and let u equal sine of kx. So we're going to do a u sub, we let u equal sine of kx, and then du will be cosine of kx times the derivative of the inside, which is k, times dx. And since u is sine of kx, we're going to want everything that's left in terms of sine. So we'll use the fact that sine squared plus cosine squared is 1. To write all remaining cosines in terms of sine. So I'm going to solve this equation for cosine squared, And everywhere I see a cosine squared, I'm going to replace it with a 1 minus sine squared. That's if the power of cosine is odd and positive. We make this substitution. And then the last guideline is this. If the powers of sine and cosine are both even and non-negative, so it's okay if one of them doesn't appear. We just can't have any negative exponents. Then we're going to use the power reducing formulas. To write the integrand in terms of cosine functions. Those cosine functions might have different angles, and that'd be okay. But here are two power reducing formulas. So you're going to replace all of the sine squareds with 1/2 of 1 minus cosine of twice the angle. And you're going to replace all of the cosine squareds with 1/2 of 1 plus cosine of twice the angle. And you can put parentheses there if you want to. It's implied because it has two, because it's a single factor that we're taking the cosine of the whole thing. So we're right there. All right, so for power of cosine odd and positive, we've got a rule. For power of sine odd and positive, we have a rule. And then for powers of sine and cosine, both even and non-negative, we have a rule. So we want to keep those in mind as we look at the next problem. So let's say you're presented with this problem. I have the integral of cosine cubed of 5x times sine to the 4th of 5x dx. So I notice that the power of cosine is odd and positive, so I'm going to factor out a cosine. I like to leave whatever is left over here in brackets, just to remind myself what needs to be written in terms of u. So I'm going to factor out one of those cosines out of that cosine cubed. If I had 3 of them here, if I take out 1, I'm going to be left with 2 of them. And because the power of cosine was odd, we factored out a cosine, and we're going to let u equal sine of, in this case, oops, that should be a 5, not a 3, 5x. So we compute du. Du is cosine of 5x times 5 by the chain rule. Don't forget your dx. And I've got a cosine of 5x dx right there, so I don't really need that 5. So I'll divide both sides by 5 to get the cosine by itself. And we have 1/5 of du is cosine of 5x dx. Alright, so this is 1/5 of du. My marker's not working for some reason. It's okay. Try to get a different color that'll work. Let's try this one. Okay, so that's 1/5 of du. All right, and u is sine of 5x. So that means this is u to the 4th. Yeah, you may have forgotten this part. Anytime you have a trig function, let's say you've tan to the nth power of kx, what that really means is we're going to take tangent of kx and we're going to raise it to the nth power. So when I see sine to the fourth of 5x. What that really means is I want to take sine of 5x, the whole thing, whatever it is, and I want to raise it to the fourth power. We just put the exponent on the name of the function because of convention, and we probably have that convention so that we don't have this mess of parentheses. You get parentheses with inside parentheses. It just looks a little bit cleaner. And we don't want to do this without the second set of parentheses either, because then it might not be clear if we're supposed to take 5x and raise it to the fourth and then take the sine of it, or if we're supposed to take sine of 5x and raise it to the fourth. So this is a very clear notation, but you do have to remember what it is. So this is sine to the fourth of 5x, so that's our u to the fourth. And now I've got a cosine squared that's left over. Now remember, we know that sine squared plus cosine squared is equal to 1. If the angles are the same, we get 1. With that in mind, I can take this cosine squared, and I can write it in terms of sine. I need to write it in terms of sine so that we can do the u substitution. So I'll solve this equation for cosine squared by subtracting sine squared from both sides. I get 1 minus sine squared right there. And the angles are the same. So this is 1 minus sine squared of 5x. And remember, sine is our u, so that's 1 minus u squared in terms of u. All right, so I've got this in terms of u, and this in terms of u, and that in terms of u. So I can rewrite this integral entirely in terms of u now. And then we can evaluate it. So that's a 1 minus u squared times u to the fourth. And that 1/5 du, I'm going to write it this way. I'll put the du on the right and the 1/5 on the left. So this is equivalent to this under this substitution. Now be careful here. You don't want to just take the antiderivative of this and multiply by the antiderivative of that. It's not how it works. In order for one of our basic rules to apply, we've got to rewrite this first. So we know, well, I don't have a rule for a product, but if I distribute that, then I can use the power rule. It's pretty much what happens every time with both of these methods. We get that right there. And now we're going to use the power rule. So we add 1 to the exponent and divide by the new exponent. Over here, we add 1 to the exponent and divide by the new exponent. Don't forget to add c. Not too bad. Just a power rule. If you want, you can distribute the 1/5 through. You don't have to. I think I prefer to. So I've got 1 over 25 times u to the 5th minus 1 over 35 times u to the 7th plus c. And then we want to back substitute. Remember, u was sine of 5x. So this is sine of 5x raised to the 5th. So I'll put that 5th power right there. Got some University of Florida colors on here. And that's sine of 5x all to the 7th power plus c. And we're done. So that's what we do when the power of cosine is odd and positive. Let's do an example where the power of sine is odd and positive. Alright, so I've got cosine to the 6th of pi x over 2 and sine to the 5th of pi x over 2 dx. Notice that the angles are the same, and I've got an even power of cosine and an odd power of sine. Whenever that happens, when one of the powers of these is odd, we're going to save one of those. I've got sine to the 5th, the one that's odd. We're going to save one of those for our du. So I'm leaving the cosine to the 6th alone. and I'm factoring out one of the signs. I have 5 of them. After I'm done factoring that out, I'll have 4 of them. You also have your guidelines. It says if the power of sine is odd and positive, save a sign for du and let u equal cosine of kx. And then you want to compute du, of course. Derivative of cosine is negative sine. The k that's multiplying our x is pi over 2. When I take the derivative of that, I have to multiply by that k, multiply by the derivative of the inside by the chain rule. Don't forget your dx. Now I need to get this sine of pi x over 2 dx by itself, because that's what I have there. So I'm going to multiply both sides by the reciprocal of that guy. So I'll multiply by negative 2 over pi on both sides. The negative and the negative will make it positive. The 2 pi's reduce, the 2 2's reduce. And so this turns out to be negative 2 over pi times du. And u was cosine, so this is u to the 6th. Now that sine to the 4th might be a little bit harder to manage. You can think of that sine to the 4th as sine squared times sine squared. Remember from our exponent properties. If you have x to the n times x to the m, that's x to the n plus m. So if I have 4 sines, I could just make that sine squared times sine squared, and I think I will. The 2 over here and 2 over here. And I know that I need to write each of these sine squareds in terms of cosine. And I can do that because of our Pythagorean identity. We know that sine squared of any angle plus cosine squared of the same angle is 1. So if I want to get sine squared by itself, I'll subtract cosine squared from both sides. So this is a 1 minus cosine squared, and that's a 1 minus cosine squared. Or, if we prefer, cosine is our u, that's 1 minus u squared, and that's 1 minus u squared. Don't forget parentheses. All right, so we've written our entire integral in terms of u. I've got that, times that, times that, and I've got my constant times du. So let's rewrite that. I'm going to factor out that constant. I've got u to the 6th, 1 minus u squared, times itself. I think I'm just going to write it as itself squared. And that constant I already factored out times du. Now, with something like this, I might think about a u substitution, but the derivative of the inside is a 2u, and I've got a u to the 6th. So u sub's not going to work. I think we're just going to have to do some algebra. This is a binomial, we can square it, and then after we square it, we can distribute the u to the 6th. So we can write it twice. I guess I didn't need to simplify it earlier. FOIL, first times first is 1. Outer times outer is negative u squared. Inner times inner is another negative u squared. Last times last is u to the 4th. And then we'll distribute the u to the 6th to each of these terms. Of u to the 6th minus 2u to the 8th plus u to the 10th. Remember, you're adding 6 to all the exponents there. Just using that exponent property again. All right. And I've got a rule for all of these, just the power rule. Oops, I don't need the integral sign anymore. I'm about to apply a rule. So we add 1 to the exponent and divide by the new exponent. Dividing by 7 is the same as multiplying by 1/7. Bring the negative 2 down. Add 1 to the exponent and divide by the new exponent. Then we add 1 to the exponent and divide by the new exponent. Don't forget to add c. And we're done. We just have to back substitute. So I'm going to have negative 2 over pi here. Then I have a 1/7. U was cosine of pi x over 2. So I'm going to have cosine of pi x over 2. And that's raised to the 7th power. So we put that 7th power on the cosine function. Then we subtract 2 over 9. And I've got u to the 9th. So that's cosine of pi x over 2. That's our u, and we're going to raise it to the 9th. And then we've got 1 over 11. And then we have cosine of pi x over 2. And that needs to be raised to the 11th power, plus c. You can distribute the negative 2 over pi if you want to. I'll probably just leave it like this. And then we're done. We're good to go. All right. Now, in the examples that we just did, the 2 examples, I had the power of cosine was odd and positive, so we made a sine substitution. On this one, I had the power of sine as odd and positive, so we made a cosine substitution. Now, you might have an example in your homework or on a quiz or a test where the power of cosine is odd and positive and the power of sine is odd and positive. Either one of these guidelines will work in that case. You're just going to get one answer in terms of cosine, the other answer in terms of sine. And because sine squared plus cosine squared is 1, they're going to be equivalent to each other, even though it may not be obvious on the surface that they're equivalent to each other. So keep that in mind. If the power of cosine and sine, if both powers are odd, the answer is going to be a little ambiguous. It's not going to be 100% clear which direction to go, because both directions work just fine. Now, if the power of sine and the power of cosine are both even and non-negative, so let's say we're looking at something like this. Say we've got cosine to the 4th of, let's say, 2x. And sine squared of 2x. Well, neither of them are raised to an odd power. Notice the angles are the same. We treat this differently if the angles are different, but the angles are the same this time. So we're going to use our power reducing formulas. And remember, cosine squared can be split up into cosine squared times cosine squared. Just because of our exponent properties. We've got 2 cosines here times 2 more cosines. There's going to be 4 of them altogether. All right. Now, because the powers of cosine and sine are both even and non-negative, I'm going to use my power reducing formulas for each of these guys. This one is 1/2 of 1 plus cosine of double the angle, so that's going to be 4x. This one is the same. And for sine squared, it's 1/2 1 minus cosine of double the angle. Now remember, multiplication is commutative. You can multiply in any order you want. So we can take out this 1/2 times 1/2 times 1/2. Make that 1/8. You don't distribute over multiplication. You can just rearrange them. And then this is 1 plus cosine of 4x. I'm going to leave that alone. And this 1 plus cosine times 1 minus cosine, I think I'm just going to distribute there. First times first is 1. Outer times outer is negative cosine. Inner times inner is positive cosine. So those reduce because these are Pythagorean conjugates. And then last times last is negative cosine squared of 4x. All of this is multiplied by dx. Now, if you want to, you could write this as sine squared now. 1 minus cosine squared of an angle is sine squared of the same angle. So that's a possibility. You could also distribute at this point. So you have two different ways that you can go. I think I'm going to go the way where we distribute, and I'll give you my reason why. If you don't recognize that that's a 1 minus cosine squared, which reduces to sine squared, you might have to do a little bit more work. And that doesn't always happen. We kind of got lucky on that one with the two Pythagorean conjugates that were multiplied together. So we could write that as sine squared, and it'll shorten our work. Or let's say we didn't notice that. Then at this point, I would FOIL again. So I do first times first is 1. Outer times outer is negative cosine squared of 4x. Inner times inner is positive cosine of 4x. And last times last is negative cosine cubed. I've got a rule for the 1, I've got a rule for the cosine of 4x. That I have to think of as a separate problem. Now it's cosine. Power of cosine is even and non-negative, so I can use my power reducing formula again. Remember, cosine is 1/2 of 1 plus cosine of double the angle. If our angle was 4x, now it's 8x. So I can distribute the 1/2 and then I can anti-differentiate that instead. That I've got a rule for. Cosine cubed, well, that's one of our rules from the previous page. So we'll handle that separately. I've got 1/8 of 1. I'm going to distribute a negative 1/2 here. Minus 1/2 minus cosine of, or 1/2 cosine of 8x. Plus cosine of 4x. Minus cosine cubed of 4x. I'm just going to leave that, or I'm going to treat that as a separate integral. So let's stop there, and then we'll say minus this, the integral of that, but don't forget to distribute the 1/8. We're going to handle that separately in just a minute. And do the easy part first. 1 minus 1/2 is 1/2. You might recognize that as a sine. If I factor out a 1/2, that's a 1/2 of 1 minus cosine of 8x. That would have been an identity, a power reducing form identity for a sine. If you don't recognize that, that's okay. But that's what we would have gotten if we had replaced this 1 minus cosine squared with sine squared. Okay. And we're going to do all this in a second. So let's just finish this one. I've got 1/8, and the antiderivative of 1/2 is 1/2 x. Then we bring the negative 1/2 down. The antiderivative of cosine of an angle is sine of the same angle. But if you have a kx inside, remember you have to divide by the k. And similarly on this one, antiderivative of cosine is sine. The 4x inside, we've got to divide by the 4. So that's that piece. We could put a plus c on it, but I'm going to add the plus c over here. So let's just distribute. We got 1/16 x minus 1 over 64. 1 over 64 times 2 is 128. Sine of 8x. Then 1/8 times 1/4 is 1 over 32. Sine of 4x. Okay, and that's that part. Now over here, cosine is, the power of cosine is odd and positive, so we have to save a cosine for our du. So I've got cosine squared of 4x times a cosine of 4x dx. And I want to let u equal sine of 4x in this case. Whenever the power of cosine is odd and positive, we save a cosine for du and we let u equal sine. So then we compute du. Derivative of sine is cosine. And then divide both sides by 4. And we're doing that again to get this cosine of 4x by itself, cosine of 4x dx. And I've got a cosine of 4x dx right here. That's why I'm trying to match it. So cosine of 4x dx turns out to be 1/4 of du. And then that's cosine squared. But I don't want that in terms of cosine, I want it in terms of sine because u is sine. So remember, if I have sine squared of some angle plus cosine of that squared of that angle, I get 1. So cosine squared is 1 minus sine squared. Or in our case, it's 1 minus sine squared and sine is u, so that's 1 minus u squared. Don't forget your parentheses. All right, so we're almost done with this guy. Got negative 1/8 times 1/4 times the integral of 1 minus u squared du. So it's negative 1/32 times our antiderivative here. Antiderivative of 1 with respect to u is u. And then use the power rule here, add 1 to the exponent, divide by the new exponent. Don't forget to add c. I'm going to distribute that negative 1/32 now. I have negative 1/32 times u plus 1/96 times u cubed plus c. And we need to back substitute. Remember, u was sine of 4x. All right, so that's that part, and I need to add that to all of this over here. So I've got 1/16 x minus 1/128 sine of 8x plus 1/32 sine of 4x minus 1/32 sine of 4x. Okay, so those guys reduce, and we get this. Excuse me. 1/16 x minus 1/128 sine of 8x plus 1/96 sine cubed of 4x plus c. So that's one way to do it. I believe that's the answer we would get if we did it the other way as well. So that's one way of handling that. All right, I have to do it the other way. I just want to see if I get exactly the same answer. So let's start right here and see if we get the same answer. So this is example 3. And we're just going to pick up where we left off right here. At this point, you can say, oh, I have a 1 minus cosine squared. That's sine squared of the same angle. Now, at this point, I would distribute the sine squared. All right. So if we saw that we could replace this 1 minus cosine squared with this, then we go ahead and do that. Then distribute. And I've got a rule for that. The power of cosine is odd and positive, so we're going to let u equal sine for this one. And save that cosine of 4x dx for du. And then on this one, we're going to use a power reducing formula because the power of sine is even and non-negative. Power of sine is 2 So we're going to replace that with a 1/2 of 1 minus cosine of double the angle. Alright, and then we're going to do a u sub over here, where u equals sine of 4x. So du equals cosine of 4x times the derivative of the inside, which is 4, times dx. And I only have 1 cosine of 4x dx here, so I'm going to divide both sides by 4. Alright, so let's do this side first, and then we will do the u sub on that side and see if we get the same answer. I've got 1/8 times 1/2, which is 1/16. And the antiderivative of 1 is just x. The antiderivative of cosine of 8x is sine of 8x. Because of the 8 inside, I've got to divide by 8. Anytime we have a kx inside, we divide by the k when we antidifferentiate. So that's that one part. Now let's do the other part. There's still a 1/8 there. Don't forget that that distributes to both terms. So if I'm just looking at the integral of this term, it's 1/8 times that. So I've got a 1/8 cosine of 4x dx. That's 1/4 of du. Includes that too. And this is u squared by design. So we end up with 1/32, and then you add 1 to the exponent, divide by the new exponent, plus c, and that reduces to 1/96 u cubed plus c. And u was sine of 4x, so we can substitute that back in. And then let's distribute this 1/16 over here. I've got 1/16 times x minus 1/16 times 1/8, 80 plus 48. What's 80 plus 48? 128? Yeah, that makes sense. And then we got sine of 8x right there. That was a little bit faster. It's a little bit shorter too, less paper. Let's see, did we get the same answer? 1/16 minus 1/128 sine of 8x, 1/96 sine cubed of 4x. Yep, same thing. So either way you go, you're going to get the right answer.